So, you might be wondering, can this thing really be used for surveying? A couple of months ago, the guys over at Moasure came to visit me and they gave me an inside look at the Moasure 2. They claim that you can use this small device to take measurements and that the accuracy of those measurements are within 0.5%. And as a surveyor, 0.5% of what? What does that exactly mean? How much accuracy can I really expect with the Moasure 2? Well, today I'm going to be surveying this vacant pharmacy and comparing the data that I get out of the Moasure 2 to what I would get with a surveying total station. I used this total station to survey this pharmacy a few weeks ago, and so the data that I collect with the Moasure 2 will be compared to the total station to see how much accuracy can a surveyor expect from the Moasure 2. Now inside this little device is an accelerometer and a gyroscope, which is similar to what we have in our smartphones, but obviously the accuracy of those gyroscopes and accelerometers are a lot less than what you'll find inside of this little Moasure 2. So how exactly does this thing work? How can you collect data using a small little black box like this? Well, the idea is that the tip right here of this Moasure is where data is being collected. The rest of these sides are all rounded, but this point right here is where you want to measure your features. So if I'm measuring the corners of the buildings, then I would hold the device up to the corner of the building. Or if I'm measuring a point on the ground, then I would actually have this device on the ground. Now I know what you're thinking. How inconvenient is it to have to drop this and then pick it up and then drop it again? Well, that's where this thing comes into play. This little stick is what you'll use to measure points on the ground. Simply take the Moasure 2 and just stick it in this little slot right here, and then there is a little corner for where your corner should sit. And so now the Moasure 2 sits nice and snug in the stick, and then you can extend the stick like this so that it's at a comfortable level for you when you measure points on the ground. So for me, something like this is good. So if I were to start collecting data here and then move over to a point over here, the Moasure 2 would be able to measure the distance traveled between these 2 points. And then if I were to come over here, suddenly now I have 2 lines and an angle between those 2 lines, and the Moasure by itself, just this little black box, will be able to calculate that angle and essentially allow us to do mapping work and possibly surveying. Now I've been messing around with this thing for a couple of months now, and truth be told, I was paid to make this video, but I was not paid to give a specific opinion. I was paid to try and use this device for surveying. And based off of my knowledge and expertise in the field of surveying, I'm gonna show you exactly what I would do to try to get the most accuracy out of this device. This device was definitely not designed for surveying, but it can be used for surveying, and there is a certain level of accuracy that can be achieved if you follow the proper surveying steps. Now, if you don't understand how surveying works and how we collect high accuracy data, then a lot of what I'm going to talk about is going to be a little difficult to follow. I'm going to talk about the control points I'm going to set, a basis of bearings for all of our layers, and a lot of other terms that we use generally in the surveying industry. And if you find yourself lost and confused about the surveying terms that we use, then I highly encourage you to check out thesurveyschool.com. At thesurveyschool.com, we offer an opportunity for highly motivated individuals to learn everything they need to know about the field of surveying. Whether that's boundary surveying or topographic surveying or legal aspects of surveying, we'll teach you everything you need to know about the surveying field in order to advance your knowledge in our industry. Everything from coursework to live coaching calls and even interactive quizzes to help you track your progress as you go through all of the content in the Survey School. Be sure to check out the link in the description if you'd like to sign up, and I look forward to seeing you inside of the Survey School. So once you've set up the Moasure 2, you're going to notice that there is a little spot here at the top for your smartphone. And so once you attach your phone up top, you're going to want to download the Moasure app. This app is what's going to allow us to collect data and store it on our phone. So immediately when I open the app, it's going to start by asking us what we want to do. And so we want to start collecting data. So I'll press this little plus button and it'll ask us what type of measurement we're taking. I'll go ahead and say we're doing a closed shape. And now it's going to ask us to connect to our Moasure 2. And so to connect to the Moasure 2, all you got to do is rotate the device back and forth there's a little blue light that is blinking, and that means that the Moasure 2 is on. And now that the Moasure 2 is on, we have a little red button on the top here that tells us to place to start. Now, if you're doing survey work, regardless of what kind of equipment you're using, whether it's a total station or a GPS or a gyroscope like this, you've got to be utilizing control points. Now, your control points don't necessarily need to have state plane coordinates, which in this project we are going to be using local coordinates. The first two control points will need to be set between 10 and 15 feet apart, or about 3 to 5 meters. This will allow us to establish the baseline for our measurements, and if we wanted to add additional layers, we'll have to visit these two control points to re-establish our basis of bearings. Now, I know survey experts will tell me you need to have a much longer baseline, 15 feet is too short. Well, again, this isn't a traditional surveying tool. The Moasure 2 is only capable of measuring data for about 6 to 9 seconds, so I really can't move that far away in that time. So really, the only basis of bearing that I can do is one that's about 15 feet away. So that's why I have that. So place to start, I'm gonna actually start here on the first control point, and then you'll see the red light will turn green. And that means now we can pick up and go to the second control point. So I'm gonna pick up. We're gonna walk over here. I'm gonna set this down here. And there we go, we've got the first control point. And now I wanna make my way over to the building. Now I'm gonna switch this over to ignore line, which will allow me to move without actually measuring any points. So now if I pick up, and let's say I set my Moasure here, you can see I've got like a grayed out point, and this is an ignore point. So I can pick this up again. I'm gonna stop here, stop here. I'm gonna pick up, go to the curb. And now I'm gonna switch back to straight line. This will now allow us to measure a straight line. So from here, I'm gonna go to this low point of the curb. And there we go, we got our first line for our curb. Cool, so we've got all these straight segments. Here we've got a curve or an arc. So I'm gonna switch over to arc, and then I can just measure a point in the middle of the arc. And there we go, it illustrates an arc for us. So now I'm gonna switch back over to straight line, and we'll measure over here. Now you might be wondering, Rami, why are you not switching between curb and gutter? Like traditional topographic surveying, we measure the curb, we measure the gutter, and then we move. Well, unfortunately, with the current version of the Moasure app, you can't switch between layers in the middle of your data collection. So we kind of have to work with the way the app is set up, which is one layer at a time. It's not the end of the world. I mean, you just have to go back and do it again. And I wouldn't really use the Moasure 2 for a large topographic survey. I'd use it on a site like this or smaller, which I can easily walk through 2 or 3 times to capture the data that I need.
Not to mention that it only took me 45 minutes to survey with the Moasure 2 Pro compared to the several hours I spent using the total station.
I'm gonna see how that looks. Oh, that looks nice. Let's do a straight line. And there's the end of that arc. Switch to straight line. We'll measure down. And so this isn't really an arc, it's more of like I don't know, a spiral. So I'm actually gonna use the trace line option. And what this will allow us to do is actually trace the feature that we have here on the curb. So I wanna be a little bit closer to the ground. Cool, and then I can switch back to straight line and finish up our curb. There we go. Last stretch here of the curb. Let's go ahead and switch over to arc. Measure here, and then measure the end of the arc, and measure to our starting point, which was right here. And there we go, we have all of the curb data. All right, so now I want to measure the gutter. And in order to do that, I need to add a new layer. So over here, I'll tap on add layer. First control point right here. And then I'm gonna pick up, there we go. And we're gonna make our way back to the building. So I'll just set the Moasure here. Just like that. So we can trace this part of the sidewalk. Right here. Step in here. Gonna come over to where we started, see how close we get. We have completed now the second scan for the project. And so yeah, now the last aspect of this project is measuring around the building. Now to do this, I'm actually going to remove the Moasure from the stick. So I just have the device, and I'm gonna take my phone out of the holder, and we're gonna create a new layer. And I actually want to measure this with my hand. So this does mean I will bend down a few times just to measure the points that are on the ground, but that's totally okay with me. Control point 1, just like that. There we go, just leave it. Cool, I'm gonna take this. So now we're measuring the corner. Pick up. Corner. We can see there is the corner that we started at. So I'll come back here, I'll close on this corner. And oh, ever so close. But that will be it. Go ahead and stop the measurements right there. All right, let's take a look at the data that we collected with the Moasure 2 Pro using the Moasure app. So here you can see the 3 layers that we collected. We can even switch this over to a 3D perspective to really see how everything turned out. So at first glance, this doesn't look too bad. I do see some error right here, some overlapping error, but overall the shape of the site is definitely there. We can see the elevation change of the building and where the curb and the gutter meet respectively. We also have the option to look at the tin of the site. So this is a tin model of each of the layers on top of each other. So that's pretty neat. But yeah, overall, I can see that the shape of the site is there, but there are some issues with this data set. But that's okay because there are some adjustment tools inside of the Moasure app that you can utilize to help improve your data. The first thing you want to do is select one of the layers. So I'm just going to come over to layers and let's start with the gutter layer. So inside of the gutter layer, I can click edit and I can start by closing the polygon that we created. So if I click on close, you can see it snaps it right into place. Another filter that we can use is the square up feature. Assuming that the initial intent of the site is to be square or rectangular in shape, you can square up your data set by using this feature. So if I come over to square up and I switch it to the low setting, you can see it kind of cleans up the data set for us. There it is. There is a medium and high option, but I don't really see too big of a difference, unlike having it turned off and using the low setting. So I'll just keep it set to low along with closing up the polygon. Next, let's switch back to a different layer. Let's go to the building layer and we're going to do exactly the same thing. We're going to close the polygon and then we're going to square it up so that looks nice. And then finally we'll come to the curb layer, we'll close it up and then we'll square it up. So these simple tools can help us improve the quality of our data before we export it into AutoCAD Civil 3D. And so to export it, all I'm going to do is come over to File, select Export, and these are the different options I have. Of course, I want CAD, and then I'll just click Export. All right, so now that we've exported our data, let's open this up in AutoCAD Civil 3D and take a look. And yeah, this is the raw data file that comes out of the Moasure 2. Now, I'm not gonna lie, this is pretty bare bones. This is definitely a classic AutoCAD file that has just basic lines and points in it. So if you are going to work in Civil 3D, you're going to want to do a decent amount of manipulation to get some of these features to be like feature lines and Kogo points. But for what we're doing, just assessing the accuracy, this is fine. This is totally acceptable. We have points, we have lines, and I like the fact that I can visualize my data in a software that I'm familiar with. And so if I come down here, you can see yep, this right here is the building, here are the curb and gutter. But here, this is the origin, right? All of them share the same origin, 0, 0, 0. And then here you'll notice that they all have the same Y value because they're all sharing the same basis of bearing for that point that was about 15 feet away. So the next thing I want to do is bring this data set next to the total station data set that we collected in another video to kind of show you what the two look like side by side. Now I'm well aware that a total station is a professional surveying machine designed to achieve sub-centimeter, if not millimeter level accuracy. Whereas the Moasure 2 Pro is definitely not that. But I just think it's impressive that we can pull data from the Moasure 2 Pro and have it look somewhat like a typical survey drawing. And well, taking a look at this, I mean, you can tell it's the same site. You can see the curb and gutter here follows the same shape as the total station. The building looks to be similar. This little island here looks to be similar. I mean, yeah, the curb and the gutter here got misaligned. The building here kind of didn't close correctly. But honestly, guys, like, this isn't half bad. For a simple gyroscope like this to be able to produce a drawing like that is actually pretty good. And remember, as surveyors, it's our responsibility to be able to assess accuracy. And so I want to quantify this accuracy report. I want to actually put numbers to it and do a point-to-point comparison to find the relative accuracy of the Moasure 2 Pro. And so if you guys remember this sketch here from the iPhone 16 Pro video, I actually extracted 23 points from the total station dataset. And so we'll be doing the same thing now for the Moasure dataset. Now the first things first is I'm going to try to align this dataset as best as I can. So I'll use the align tool to select everything. We'll then take point number 1, align it with point number 1 on the total station data set, and then the second point, align it with here. No scaling. So now we've aligned the two data sets to each other. We can take a look at the Z-plane here real quick. Yep, the Z-plane looks to be pretty good. I'm just gonna copy this back over to a new drawing. So now we're in a new drawing, and this is the first point, point number 1, and you can see the coordinate is 0, 0, 0. So we're back to our local coordinates that we measured with the Moasure. We're not using state plane coordinates because there's no GNSS involved. It's all relative measurements. So we're going to be working with a local coordinate system, but again, we're evaluating the relative accuracy here, so we don't really care for absolute positioning. Hopefully nobody got lost there. If you did, maybe you should enroll in the survey school. Here's our sketch. I'm going to change the colors of these layers so I can differentiate between them. So yellow will be building. Let's make curb white, and let's just keep gutter cyan. Point number 1 is going to be B for building. Looks like point number 2 is the curb. We said curb was white. So C for curb. And then this right here will be point number 3, G for gutter. Point number 4 is this building corner. So this will be B for building. Point number 5 is right here, also B for building. Point number 6 is the curb, C for curb. Cyan is gutter. Point number 8 is the curb. Point number 9 is G for gutter. Points number 10 and 11 I'm gonna skip because we don't actually have any data there. So we'll just jump right into point number 12. Point number 12 is the building corner, B for building. Point number 13 is the curb. Point 14 is the gutter. And then looks like 15, 16, 17, and 18 are all the concrete pad, which we didn't measure. So again, we'll skip those 4 points. Point 19 looks to be the start of this curb and gutter. So this will be curb, and this will be gutter. Point number 21 is the curb, 22 is the gutter, and then it looks like point 23 is the building corner, and I don't know which corner I want to pick. Guess I'll just pick this top one right here. Okay, so cool, we have all of our points here. All right, so I'm gonna export the coordinates from this data set and bring it into Excel so that we can compare the Moasure with the total station. This right here is our master Excel sheet. Up at the top, these are the coordinates for the total station. We did this for an older video, so I'm just reusing the data that we have. And these right here are the coordinates of the Moasure 2 Pro. Now again, these are local coordinates. We're not using state plane coordinates. And the way that we're going to compare the data is by using relative positioning. So what does that mean? So up here where it says difference between TS points, we will do a coordinate geometry between two of the points, let's say points 1 and 2. So I would take the difference in the Y values, the difference in the X values, and the difference in the Z values, and compare them to each other inside of the total station data set. Then we would go down and do the same thing value over here between 1 and 2 on the Moasure dataset. And then up here where it says difference between TS and Moasure 2 Pro, this is the difference of the differences. Once we find the differences of the differences, this column is the 2D RMSE, so basically the 2D quality, how accurate is the root mean square error, and then we convert that to centimeters for our metric users. And then the 3D quality, the 3D RMSE, and so that uses X, Y, and Z. And then obviously we convert that over to centimeters. And so we'll just do a random point-to-point comparison inside of the data set. One other thing I want to mention is that I did remove all of the elevations for the buildings. The elevation shots here are all ground shots. We did not take ground shots with the Moasure. We lifted up the Moasure and measured it up against the building. So it's not fair to use the elevation for that layer, but the curb and gutter layer, totally fair game. Let's start easy. I think if we were to just take a difference between points 4 and 5, these are two building shots. Let's just see what that looks like. So again, I would come over here, I would say 4 to 5 in our Kogo, and then we'll say equals the y of 4 minus the y of 5. There we go. And then I will just drag this across to get our x value as well. I'm gonna skip z because we don't have a z value over on the Moasure. And so over here, we'll do the same thing. Here's 4 minus 5. And then we'll drag this one over. It looks like we've got a change in y and x of about 15 feet each. And it looks like the error is about 4/10 of a foot. And it looks like it's coming out of the y direction. The x direction is pretty good actually, it's right on. Okay, so now let's do something else. Let's try to compare between points 8 and 9. This is a curb to gutter shot. We have the northing of 8 minus the northing of 9, and we'll drag that out for X, Y, and Z. And then I'll copy this over here. So it's doing the same thing here, 8, 9, 8, 9, 8, 9. And it looks like we've got about 6/10 in the Y, 6/10 in the X, but 8/100 in the elevation. So the elevation is actually within about 2 centimeters, but the overall 2D quality is about 26 centimeters. It's a small shot between the curb and the gutter, but honestly, I think most of this error is coming from the fact that they were measured at 2 different times. Had it been measured like here's the curb, okay, now here's the gutter, I think this would have been a much more accurate way to measure it, instead of going all the way around at a gutter and all the way around at a curb. And I think that's what we're gonna see with a lot of these shots. Let's take a look at point 8 all the way down to like point 13. So these are 2 curb shots that we measured between. We've got about 1.75 feet in the X value and about 1/2 foot in the elevation. So truly most of the error is coming in on the X value, which is the distance left and right, but the actual measurement, the distance, it hit right on to the 100th. But still on the 2D quality, you've got about 53 centimeters, and then on the 3D quality, you've got about 55 centimeters. That's very interesting. I kind of want to see this again, but over on this side. So let's try point number 3 and measure over to point 21. Not as good. I think that was a fluke, but here we've got pretty similar results. 3.3 feet and 2.5 feet. Also an elevation difference of about 1/2 foot, so that's interesting to see. But yeah, in terms of 2D quality, we got about 4 feet or 126 centimeters. And in the 3D quality, that is 127 centimeters. And again, this is a distance of about 140 feet, which is about 42, 43 meters, something like that. So that's the kind of accuracy I'm getting. So let's try another building here. Let's do 5 until 12. We're only going to do X and Y here. So it's a distance of 115 feet again, and we've got about 1.6 feet error in the Y direction and about 1/2 foot in the X direction. So our 2D quality is 1.73 or about 53 centimeters. So let's try the other side. Let's try 1 and 23. Yeah, looks to be pretty similar. I mean, that X value is pretty solid, 3/100 of a foot. We've got about 2.5 feet in the Y direction. So 2D quality, 2.5 feet or about 77 centimeters. Between 2 and 3, I know really did not turn out that well. This is near the end of the site, so let's see how that looks. It is about 3 feet off in the Y direction, but it's only 1/10 off in the elevations. 2.8 feet in RMSE for both 2D and 3D, which is about 86 centimeters. I want to check between 6 and 7. All right, so it looks like the difference is about 7/10, so just under a foot. So we're looking at about 23 centimeters of error. Elevation is actually right on. Very interesting, I like that. All right, let's do one more. I'm gonna do a really extreme one here. I'm gonna do point 3 to 14. Let's do that. Okay, and we've got, actually not as bad as I thought. It looks like 0.83 and 0.54. It is quite a large distance, but I think from end to end, yeah, it looks like an RMSE in the 2D of 1 foot, or in 3D 1.06. So yeah, about 30 centimeters. And so if I do equal average and take a look at the average error, it looks like we got an average about 1.8 feet, or about 55 centimeters. And this project spanned about 1,500 feet of mapping. And so my final thoughts about the Moasure 2 Pro: if you're going to be doing residential or small commercial surveys, then anticipate an error level of about 2 feet, or roughly 60 centimeters. Special thanks to Moasure for sponsoring today's video and giving us a chance to survey using their Moasure 2 Pro. If you guys are interested in learning more about them, check out the link in the description. And if you're interested in expanding your knowledge in surveying, then be sure to check out thesurveyschool.com. Thanks guys for watching, and I'll see you all next time.